Good afternoon. Welcome to the chapter on hypothesis testing. In the next question, instead of asking you to find justify whether the claim is true or not true, the question asks you to find the least population mean such that the null hypothesis is rejected at a given level of significance. Without further ado, let's look at the question. Now, in this question, it is given that the population is normal. Is normal, right? Now, the population mean is not given, and the variance is also not given. Now, what are the information given from the sample? It is given by the following information are given in the sample. Summation of x minus 200 is equals to 180.2. Now, what else? It is also given that summation of x minus 200 whole thing squared is equals to 862.1. Now, we are asked to find the value of mu such that it is rejected, the least value of mu such that it is rejected at 5% level of significance. So let's write down the null and the alternative hypothesis. So you have your null hypothesis, H naught is greater than H is mu naught. Mu naught is the one that we want to find. All right. Now, H1 is the alternative hypothesis. So the alternative hypothesis is always against the null hypothesis. So it's smaller than mu. Level is given that level significance is 5%. Now, what can we say about the distribution of the sample mean? Now, if the population is normal, then the sample mean will have this distribution, will also be normal with mean mu and sigma squared over n. Will be given by summation of x minus 200 divided by n. N is 120. So let me fill this up over here. Fill this in. N is 120. So this is 120. Okay. Now, we need to do some adjustment because the mass of every item we minus 200. So we must add 200 to it. All right. Because when we minus each of them minus 200, that means the average will also be minus 200. So we need to add 200 as a correction factor. And for that, it comes out to 201.5 gram. Okay, I will leave out the units. Now, what about sigma? The population variance is not given. All right, so we must estimate the population variance. How do we estimate the population variance? We estimate the population variance using the sample variance. That is, S square is equals to 1 over n minus 1 summation x square minus summation x whole thing squared over n. Right, this is the formula. Now, but given that x minus 200 and not x. Now, remember this property where variance x will be equals to variance x plus a. Right. Now, because of such, you don't need to do any correction factor over here. All right, so you can just simply substitute this inside here and you will get the sample variance. Now I have done a lecture on this. All right, why is it the same? Maybe if you want to know more more about it, you can look up at the via the URL link which is listed below. So n is 120, so n minus 1 will be 119. All right, then this you have 862.1 minus 180.2 squared over 120 and close bracket. Now you can key this into your GC and then you get 2.2295 gram. Okay. Now you are asked to find the value of mu naught so that you reject the null hypothesis. Now let's look at it graphically. What does that mean? Let me draw the normal curve first. Now, let's say this is the 5% level of significance. I use a different color. So this is 5%, right? 0.05. Now this is the standard normal graph. Now you want this to be rejected. So your t statistics must lie on this side of the, this is your z statistics, your z test, because you are doing the z test. Now if you use the t test, then this will be the t statistics, okay, which I will explain later, because this sum, you want a more accurate answer, you can use the t test. Now after doing the z test, I will do the t test. All right. Now, so this z statistics must lies on the rejection region. Okay. Now, so you want the z statistics to be less than, now what is this value? This is 1.645. Okay, Now minus 1.645. Because this is a standard normal. So the standard normal will be symmetrical about the mean, which is 0, 1. Okay, so this is negative. You want your Z statistics to be less than 1.645. Now, how to find the Z statistics? So you have your Z statistics will be given by Z will be equals to x bar minus mu over sigma over root n. Now in this case, your sigma is actually, because you don't know sigma, so in this case it will be your s. All right, this should be s square, not s, sorry. This part should be s square. Now instead of writing sigma, this should be s because sigma is unknown. So maybe I just cancel. So how to find this value? Now my x bar is 201.5. So it will be 201.5 minus my mu naught over my s, which is 2.2295 over root n. Root n is root 120. Okay, now you want this to be less than minus 1.645. Okay, substitute the relevant values. Now your x bar is 201.5, so this will be 201.5 minus, now mu naught is the one that we want to determine, over, what is s? S is 2.2295, 2.2295 over sigma, over square root of n. N is 120, so square root of 120. Now this must be less than minus 1.65, because in order for it to, because we want to reject H naught. So to reject H naught, your test statistics has to be less than minus 1.65. 1.645, I mean. Now if you go ahead to solve this inequality, you will get mu naught to be greater than 201.83 grams. Now, but you want the least possible and you want to correct it to 3 significant figures. So 3 significant figures, so mu naught will be equals to 202 grams. All right, that should be the answer if you use your Z statistics. Now, what happened? Can we use a t distribution to do this? Yes, in fact, it is more accurate. Now, because sigma is unknown, so we use, but your sample size is huge. So your distribution will be close to a normal distribution. Now let me show you, all right? Now assuming if n is small, then you find that your t distribution will be much lower than this. It will still have a mean of 0 and standard deviation of 1, all right? Because it's based on the standard normal distribution for the t distribution now. So it will be lower. So this will be your t distribution. But as n increases, as the sample size increase, you will find that your t-distribution will be closer and closer to the normal. So imagine this is n is equals to, let's say, 70. Now, as n increases, you will find that your t-distribution will become very close to the normal distribution. Will it be exactly the same? No. So your t-distribution will be very close. Okay? Now, because if it is very close, then your test statistics will also be roughly the same value. Now, if n is small, you will find that this value will need to shift a lot more to the left, all right, because to compensate the difference. Okay? Now, so since n is large, so your t-distribution will be very close to your normal. So if you do the using the z-score, all right, your answer will be rather close to the t-score. But which is more accurate? The t is more accurate. So let us do it using the t-statistics. Now, you will find that the t-score remains unchanged. All right, so your t-statistics will still be the same. Now, this will also be your t-statistics, because the t-statistics, is based on the normal, all right, normal distribution with some correction factor, and the correction factor is the degrees of freedom. So this is also equal to your t-statistics. Now, but this value will change, all right. Now, if you use your GC, okay. Now, if you do an inverse t distribution, you go to your distribution, you go to inverse t distribution. Now, if you put the error as 0.05, all right, this is your inverse t distribution. If you put your error as 0.05 and the degrees of freedom, you put 119. Now, you will find that this value, okay, will be minus 1.6577. Okay. Now, if you do the inequality, now what will you get? You will get mu naught must be greater than 201.152. So you look at these two answers, is very close. Okay. Now, and then your final answer will still be the same.